One of the most captivating celestial phenomena is the impending supernova of Betelgeuse, positioned in the prominent shoulder of the constellation Orion. Betelgeuse is a crimson supergiant nearing the culmination of its existence. Unexpectedly, in 2019, this brilliantly glowing star began to perceptibly dim, visible even to the naked eye. For several months, its luminosity diminished to such an extent that numerous observers speculated whether the star was undergoing its demise. Directing their telescopes to the colossal star, researchers were astonished by evidence of its substantial fading. Betelgeuse is believed to be on the brink of exploding into a supernova, signaling the conclusion of its stellar journey. Could it pose dire consequences for our planet? The luminous scarlet star Betelgeuse is located on the upper right shoulder of Orion the Hunter. You might recognize it by its alternative designation, Alpha Orionis, even though it's the second most brilliant star in that constellation, surpassed only by the supergiant Rigel. It continues to fascinate scientists due to its erratic behavior and distinct name. Alpha stars are typically the brightest within their constellations, and although Rigel outshines it, Betelgeuse garners attention due to its immense dimensions and reddish hue. Betelgeuse, also known as Alpha Orionis, ranks among the most celebrated stars in the nocturnal sky, being the 10th most luminous and 7th most discernible across much of North America, Europe, and Canada. Its appellation originates from Arabic and signifies the armpit of the giant, referring to its placement within the stellar grouping. Betelgeuse expels approximately one solar mass every 10,000 years, uniformly releasing material in all directions and forming a nebula around itself. This nebula stretches 30 astronomical units, 30 times the distance between Earth and the Sun, and is 250 times more massive than the star itself at its nucleus. Betelgeuse's hydrogen nuclei fuse under immense gravitational force, generating helium and emitting radiation and heat in the process. As the star exhausts its hydrogen, it commences fusing helium and carbon as replacements. When helium is depleted, neon combines with carbon to produce iron. The fusion of iron fails to generate energy, causing the star to collapse under its own gravity and ultimately detonate into a supernova, among the universe's most powerful cataclysms. Stars radiate light in various wavelengths depending on their age and developmental stage, from a vibrant blue of nascent stars to the red of aged ones. According to the ancient astronomer Ptolemy, Betelgeuse exhibited a shade he curiously labeled as ruddy. Nevertheless, early Chinese astronomers noted that Betelgeuse appeared yellow, suggesting it may have once been a yellow supergiant. Massive stars rapidly consume their hydrogen fuel, leading to a premature demise even if their lifespan extends to only 10 million years. There's no doubt that Betelgeuse is in its final phase. While our Sun still has over 5 billion years of life remaining, Betelgeuse is approaching its ultimate moment, implying it could someday erupt in a supernova. However, the precise timing of this event remains uncertain. Betelgeuse undergoes 2 cycles of brightening and dimming, one occurring every 5 years and lasting approximately 100 days. It's presumed that the expansion and contraction of its external layers during these cycles cause alterations in its diameter and typical surface temperature. Widespread fascination with Betelgeuse surged during its erratic performance in 2019 and 2020 when its light faded considerably before briefly recovering. Some scientists have hypothesized that this unusual activity could indicate the star is nearing its ultimate metamorphosis. Thorough examinations of Betelgeuse date back to the 1st century BC, yet the genesis of its dimming remains a complete mystery. Betelgeuse has been observed traversing the interstellar medium at roughly 30 kilometers per second after being ejected from its stellar nursery in the Orion OB1 group, which comprises the stars of Orion's belt. The resulting bow shock extends beyond 4 light-years. Determining the proximity of red supergiant stars like Betelgeuse is a notoriously arduous task in astrophysics, as various factors impede precise diameter estimations. Furthermore, since it's a pulsating star, Betelgeuse's dimensions fluctuate over time. This characteristic, coupled with the dimming of its outer edge, causes its perceived glow to shift in color and lessen as we observe it further from its core. Additionally, the expelled shell of material from the star plays a crucial role in light emission and absorption, also influencing how we interpret its brilliance. Directly comparing views of Betelgeuse is complex because its visible size changes with the observed wavelength. These measurements can fluctuate by up to 35% based on the segment of the light spectrum utilized. In July 2009, the European Southern Observatory unveiled images captured with a very large telescope, VLT, interferometer at its ground-based facility, revealing a massive plume of gas extending up to 30 astronomical units from the star's surface. This was one of many mass expulsions witnessed from Betelgeuse, an outflow that mirrored the angular distance between the Sun and Neptune. At least 6 such occurrences have been identified around Betelgeuse. These events might offer insights into the phenomenon of mass ejection during the final stages of massive stars, which may be central to their destruction. The intricate processes within Betelgeuse's expansive upper layers continue to perplex, as does the exact mechanism by which red supergiants shed their matter. Such stars are fundamental to the cycling of elements within galaxies, and due to advancements in interferometry, astronomers are nearing solutions to these enigmas. In 2019, scientists employing the Hubble Space Telescope and other observatories discovered that Betelgeuse had ejected a significant portion of its outer shell, triggering a substantial surface mass expulsion, SME. Although the Sun generates solar mass ejections, Betelgeuse's events were thousands of times more extreme, with this event expelling material 400 billion times the mass of a typical solar eruption. This explains why Betelgeuse experienced a sharp decline in luminosity in October 2019. By mid-February 2020, it had lost nearly 3 times its brilliance, shifting from magnitude 0.5 to 1.7. By February 17, 2020, Betelgeuse's brightness had remained largely consistent for over a week. On the 5th, it appeared that the dimming had completely ceased. However, the recent reductions in visible light were not linked to a probable core collapse, as no notable changes in infrared radiation were registered. On February 24, 2020, Betelgeuse's dimming stabilized, leaving astronomers puzzled yet intrigued. When Betelgeuse ultimately explodes as a supernova, it will be among the most spectacular cosmic events ever recorded. Even at a distance of 640 light-years, the blast will be so brilliant that it could outshine the full moon and even be visible during daylight for several weeks, even months. Experts estimate that the supernova will unleash more energy in mere seconds than our Sun will emit throughout its entire 10 billion-year lifespan. The illumination from the explosion will traverse space and eventually reach Earth as an astonishing pinpoint of light, unlike anything we've ever witnessed. But rest assured, we are completely safe. Although a supernova so close might sound menacing, Betelgeuse remains sufficiently distant that the detonation will not harm Earth's biosphere or its living organisms. What it will do is present an extraordinary scientific opportunity. In recent years, Betelgeuse has reverted to typical brightness levels, but its irregular dimming patterns remain under intense scrutiny. Scientists are utilizing instruments like the James Webb Space Telescope, the Hubble Space Telescope, and terrestrial interferometers such as a VLT and ALMA. They are monitoring surface light fluctuations, patterns in convective activity, and continuous mass outflows that appear to reflect the star's instability. A well-supported hypothesis suggests that Betelgeuse's significant fading was caused by a colossal cloud of stellar dust generated during one such eruption, temporarily obscuring the star's light from our perspective. Comprehending the mechanisms behind Betelgeuse could aid astronomers in deciphering the life stages of colossal stars, particularly those on the verge of undergoing a supernova. Such insights could help predict similar phenomena in other galaxies, elucidate how chemical elements enrich the cosmos, and detail the creation and dispersal of elements like iron and gold throughout space. Betelgeuse is essentially a ticking cosmic clock, slowly winding down. It might explode tomorrow, next year, or in 100,000 years. But whenever it does, it will offer a galactic spectacle and a wealth of scientific data unparalleled in modern times. Understanding the life and death of stars like Betelgeuse is not merely a matter of academic curiosity. It plays a pivotal role in shaping our comprehension of the universe itself. Massive stars are the crucibles in which heavy elements are forged. When these stars reach the conclusion of their life cycles and erupt in supernovae, they scatter these elements into space, enriching surrounding interstellar clouds with the fundamental components for new stars, planets, and even life. Betelgeuse's impending supernova presents a rare chance to study such an event in relatively close proximity. Most supernovae observed by modern science occur in remote galaxies, limiting the detail and data scientists can acquire. But with Betelgeuse in our own Milky Way galaxy and comparatively nearby in astronomical terms, astronomers could monitor every phase of the explosion and its aftermath with unprecedented clarity. This potential observation is particularly thrilling for those investigating neutrinos and gravitational waves. When a star collapses into a supernova, it doesn't just release visible light. It emits colossal quantities of neutrinos and may generate detectable ripples in space-time. If Betelgeuse were to undergo a supernova, detectors such as LIGO, Virgo, and IceCube could capture this data, offering new insights into both stellar physics and the fundamental forces of the universe. Moreover, astronomers are paying close attention to Betelgeuse not only because of its potential demise, but also because of what it can teach us about stellar behavior in general. Red supergiants like Betelgeuse remain among the least understood stages in stellar evolution. They are immense, volatile, and challenging to model accurately. Advancements in space telescopes and high-resolution spectroscopy are helping to alter that, but many unresolved questions persist, questions that Betelgeuse might soon help answer. In the interim, Betelgeuse continues to glimmer, pulse, and surprise us. Its brightness may seem stable for now, but scientists remain vigilant, prepared to capture every fluctuation. In the event of a supernova, the collected data could revolutionize our understanding of how stars live and die. Until that moment arrives, be it tomorrow or millennia from now, Betelgeuse will remain a focal point in the night sky and in the imagination of astronomers everywhere.